In this lesson, we will cover Unit 7, Section 7.2, Solving a System of Linear Equations Graphically. In this lesson, you will learn how to use the graphs of the equations of a linear system to estimate its solution. Then we'll explain the meaning of the point of intersection of a system of linear equations. So first, let's look at what a point of intersection means. Point of intersection is the point where the two graphs will intersect. The solution of a linear system can be estimated by graphing both equations on the same grid. If the two lines intersect, the coordinates x and y of the point of intersection are the solutions to the linear system. So many times you're going to be given a question that will ask you to determine the point of intersection. You'll take the two equations that are given and you're going to plot the lines on the coordinate grid using your slope and your y-intercept. And the point where the lines will intersect or meet will be your point of intersection. And you're going to end up with a x and y coordinate for your solution. However, when you do this, it's going to be a little hard to read the points sometimes off the graph using an accurate decision. So what you're going to need to do, you're going to need to verify this coordinate of the point of intersection and make sure that that point will actually satisfy the left-hand side and the right-hand side of your equation. And once you substitute this point in for your x and your y, you will decide if the point is accurate and if it is actually correct for your situation. When you graph linear systems, there are many ways to do this without technology. You can put your equations in slope-intercept form. You can write it in slope-point form, or you can use the x and y intercept method, where you would let x equal to 0 to find your y-intercept and y equals 0 to find your x-intercept. So what you need to do here when you're given equations, you need to identify what form the equation is given in and then decide what form to rewrite the equation. Some methods and some equations are a lot easier to read the slope and the y-intercept from. A lot of the times equations can be rewritten in slope-intercept form where the slope and the y-intercept are easily read. It's important to note here also that when you graph linear systems, you're able to use your TI-83 graphing technology to easily see a visual representation of your equations. And this could be another method to check your solutions besides using the substitution method. So our example here, we have 2x plus 3y equals 6 and x subtract 2y equals 6. And they're going to ask us to actually graph these lines on a coordinate grid. Maybe they'll extend the question by asking what the point of intersection will be. If you notice, the equations are not given in any recognizable form. They're not general form, it's not slope-intercept form, and it's not, or slope-intercept form, and it's not slope-point form. So what we're going to do, you're first going to rewrite both equations in slope-intercept form to help determine the slope and the y-intercept. When you do this process, you will end up getting two equations that have been rewritten in a form where we have y equals negative 2/3 x plus 2 and y equals 1/2 x subtract 3. So once you get those equations now, we can easily see that on the left-hand side, we have a slope of negative 2/3 and a y-intercept of 2. This will be a decreasing line. The equation on the right will have a slope of 1/2, a positive increasing slope, and the y-intercept will be negative 3. As you can see here, these two equations have been graphed using FXdraw. You could do the same process yourself using your graphing technology TI-83, or you can actually graph it using the slope and a y-intercept on a coordinate grid. When you do this, you will notice that the two lines will intersect or meet at the point that is shown, 30 divided by 7 and negative 6 divided by 7. If you want to estimate the point of intersection, you can also rewrite those as decimal form. Keeping in mind that you should verify by substituting back the x and the y point into both equations to ensure that the left-hand side does actually equal the right-hand side. Because when we read them off, the point, we may not be able to do so in an accurate way. So we're just going to make sure and double check our answers always. Now in summary, when we're looking at a point of intersection, you will look at the graph. The point of intersection is where the two lines will intersect or will meet. So as you can see from the graph here on the left-hand side, the solution was identified where x equals 45 and y equals 40. You'll use the equations that were originally given, 12x plus 24y equals 1500, and x subtract y equals 5. And you're going to use those two solutions, x equals 45, y equals 40, to verify the solution. Once your problem has been verified and both sides of the equation are equal, then we know that we have a suitable and approximate solution. As we keep going in Unit 7, we will learn how to find our solution using an algebraic method of substitution and elimination. But keep in mind that when we want to solve using graphical methods, it oftentimes is only an approximate solution.